So the second speaker is Kerstin Bischoff, and she's going to talk about We Love Rock and Roll. And by the way, the paper appears on page 59 in the proceedings if you have access to electronic proceedings.
Okay. So welcome everybody. I'm going to present the paper Analyzing and Predicting Friendship Links in Last.fm. So you probably agree that sometimes it's pretty striking that there is such a phenomenon like musical bonding. You see sometimes friend pairs or people where you can really tell that music and shared taste is pretty a building block in their relationship. And the psychology of music, this phenomenon has been studied for a while, and they found that values are probably the missing link in explaining that. So there are some results that say that certain types of music, some genres are associated with certain values. For example, rebellious music, so rock music is often associated with openness and less with self-enhancement, for example. And it is this perceived similarity in values that then leads to, transported by shared musical taste, that then leads to this social attraction. There have been other areas a lot where this phenomenon of having relationships with people that are similar to oneself has been reported. It's often called homophily, and also partially due to social influence. It means becoming more similar due to maintaining a relationship. And it is said to increase with tie strength. What I'd like to invite you to now is to look in more detail to the music social network Last.fm, and to analyze along two notions of friendships, the binary explicit friendship link as we know it, and an offline proxy, namely co-presence at shared events, and to study the similarity that we find along these links regarding structural, demographic, and taste-related attributes, and also to test whether this similarity increases with tie strength. And given that we find some similarity, can we use then this similarity to predict those relationships automatically. The Dataset is Last.fm, a music social platform. The main focus or the main reason for users to go there is to stream personalized radio. They have a recommender systems, and you can also have a library of the songs that you listen to recently and often. The site claims about 40 million users as of September last year, 2 years ago. And it has, besides this music, also some social features, like you can write messages, and you have a public wall, so-called shouts. And you have friends and neighbors, also some taste comparisons, tasteometer, and interestingly for the task at hand, they also have an event calendar. So you can, if you like, list events that you're going to attend and with whom. And we will use this as a proxy for this offline relationship. We gathered around 320,000 user profiles, including for each user the undirected friendship links, the demographic data available, that was gender, age, country, public interaction if present, so there's shouts that are on the wall of each user, and a lot of taste preference indicators. So we got the tags of the user, we got the different kind of tracks, the recent one the user listened to, the top ones, the ones he positively rated, he loved, or the ones he negatively rated, he banned them, some information about albums, artists, and past and upcoming events. Among these 320,000 users, around 48,500 had used this event calendar, and we're going to focus on this subset sample now for the rest of the analysis. And as you can see, this distribution of event co-attendance for all people, the upper line, follows more or less a straight line on a log-log plot. Just to get an idea of those two different relationships, of these two different networks, if we calculate the intersection between the two, the overlap, we see that around 26% of the friendship links also coincide with an event attendance link, meaning that around a quarter of friends are also connected offline. For a random friendship model, this is negligible. So let's now analyze this similarity. We do this by comparing two samples, the one that are already friends on Last.fm and the one that are not friends, so randomly paired users. And for the categorical variables, gender and country, you do a chi-square test, where the observed frequencies of user pairs having actually the same attribute values are contrasted with the ones that would be expected if I assume random pairing. And the higher this observed over expected ratio is, the more likely the chance it is that two users share the same attribute. And for the numerical attributes, we report mean to get an idea of how distinct the two subsamples are, the autocorrelation between the user attributes and correlation with the offline tie. So first results for the demographic data, gender and country. There is a slight, while for the not friends, both are perfectly around the expected frequencies, around 1. We see that for online friends connected online, there's a slight tendency for mixed gender friendship. But if we look at the more narrowed, the offline network, then we see that this trend is reversed. Now slightly in favor for same gender pairs. For country, not surprisingly, there's a strong affinity. For friends already, it's 8 times as likely that two friends come from the same country, probably also due to language. And for offline friends, well, not surprisingly, it's even stronger with 12 times as likely. This becomes even more obvious if we look at the absolute distance. There it is almost, the distance is half as high for friends than for non-friends, and it correlates quite a little bit with the offline tie, so on the right hand. And this linear Pearson correlation coefficient actually underestimates the strength of the relationship. If we transform it into log-log, then the relationship is about, the correlation is about 0.52, so negatively. Age follows a right-skewed distribution in both subsamples around the age of 23 as a mean. And then with a fat tail flattening out for the older ones. And friends are, as the autocorrelation shows, friends are a little bit more likely to have the same age, so the age difference is a little bit smaller than with non-friends, randomly compared. Structural, we had a look at some structural variables, which give a little insight about the embeddedness of the user pair. We looked at degree as a sign of social activity, also exclusiveness of the friendship, and we see that our online friends are slightly a bit more active than the other ones, the non-friends, and users also tend to have a relationship with users that also have are similarly active. There is, however, not a real correlation with this offline event co-attendance. Mutual friends is more important for the task at hand. Users have around 3.5 mutual friends if they are connected online. And this correlates nicely with this offline tie. So common friends increase the likelihood that you attend an event together. And this frequency distribution of mutual friends follows a Zipf power law with an exponent around 1. One further aspect we looked at was like Jean Kleinberg said before, this balance theory, this forbidden triads, that actually in a triad there shouldn't be just 2 links closed, then it would be forbidden or unbalanced. And according to Granovetter, that should even be the closer the 2 ties are, the 2 people, no, the stronger the ties between those 2 pairs are, then the less likely it should be actually that the 3rd link would be missing. So we counted for the triads in our friendship sample, we counted how many of them are forbidden. And the left bar is for the online network, just counting the forbidden triads. We see that it's 0.06 of all the triads that have at least 1 edge present are forbidden. So the online network is already pretty balanced. And then if we look at the forbidden triads for offline networks, the more co-attended events we say they have to fulfill, then the less likely the 3rd link is missing. So this is nice support for the theory. And let's come to the taste, the focus actually of the study. We can see that in general, if you look at the left for the online friends and also for the not friends, similarity is rather low. except for top artists. This is probably due that tracks are too fine-grained, the granularity is too high probably in that case. And also their correlation with an offline tie is actually only given for the top artists. But there it's different, it seems to differentiate the online friends from the not friends. And we also did some experiments where we can see that the more of your close friends listen to a song at a certain timestamp, and then you look at it 2 months later, the more close friends listen to a song, the more likely you will also listen to the song. But I have to point you for the paper to that due to time constraints. So what we say we find affinity regarding location, common friends, and artist overlap. However, if we take all the variables together, there were some more, but I left them for because they were not so important. Then it gets a little bit more complicated if we look at the partial correlations. Then the importance of taste diminishes in explaining the variance of tie strength. And it's mainly mutual friends that have the highest value, and also distance still a bit. But there's also quite some correlation between these two variables. So we did some last experiment for using machine learning to better understand how to combine the variables. So we predict online ties and offline ties using the machine learning library Veka, especially classification via regression on decision trees. And we did, for the offline tie, we did some runs predicting the binary link, yes, there is an offline link or not. And we used some notions of absent, weak, and strong ties with a clear border and one with a fuzzy overlap, how we in defining the how much co-attendance is necessary to talk of a strong tie. And as features, we used more or less the ones I showed. And as well, interaction data, because it had been shown for Facebook to work nicely in predicting tie strength, and also the most in the social sciences, the most tie strengths indicator are based on interaction. We used the minutes since the first and last communication, pointing more or less to duration and recency of the relationship within Last.fm, the number of shouts as a frequency variable, length of shouts for intensity, and the polarity, so positiveness and negativeness of shouts. And for assessing the quality of the prediction, we used the classification accuracy of a cross-validation, and we also did some comparison with a very simple variant of user-based collaborative filtering, more to also give evidence on the value of the different kinds of features. For that, I also point to the paper. And for assessing the value of the different attributes, we use correlation-based feature subset selection, which tries to find a subset of attributes where each attribute correlates strongly with a class to predict, but doesn't correlate with the other variables, and information gain for the individual attributes. For predicting offline ties of event co-attendance, we achieve around 82% accuracy for friends, and 91 for non-friends. And we achieve more or less a similar accuracy if we use this fuzzy variant of absent, weak, and strong ties. The stronger definition, the clear border didn't work so well, which points to the fact that to draw an exact border is pretty difficult. And this correlation-based feature subset selection considerably reduces the feature set. In the end, we had around 6 or 7 features that were interesting for the task. For friends, it's of course, again, distance and same country as location. The number of common friends is pretty important, and interaction, if there is interaction available. Here, the frequency was sufficient. All the other dimensions didn't really add new information to that. And for non-friends, well, location, of course, and here taste is much more discriminative, so it has a lot more impact on that. And also common friends. If you know that some unconnected users have common friends, then it is way more likely that they also attend some event together. Predicting online ties was, in comparison, a lot easier. We had around 94% accuracy. And also here, this feature selection helped quite a bit, and we had, in the end, 5 attributes. Here, same country is important, but not the absolute distance anymore, because of course, on an online network, it's a little bit more, it's easier to maintain relationships, even though there is distance. But same country, maybe due to language or culture, shared background. Degree also as a general tendency for how much social interaction you may have, you may like. And communication, of course, if there is some, then it is a strong hint. And taste is quite indicative. If you take that alone, you achieve around 80% accuracy compared to 50 that a baseline classifier would have in a balanced data set. And 84% is the value of for mutual friends taken alone. So this is the most indicative feature for the task. So to wrap up, this was the study along two notions of friendship in an offline and an online network, and we found increasing affinity on location, so distance and country, and artist overlap, also overlapping social circles. And however, that this, even though we found this tendency to have shared tastes with friends, that they are not really predictive, or they don't have any added value, for example, about mutual friends. But they have for predicting online friendship or offline event co-attendance for people that are not connected. Way easier tasks. Well, this points probably to the importance of other social aspects, and it would be quite interesting to have some other communication data as well. So either private communication or in other networks, that would be even better. And the bad performance of this interaction data is probably due to the nature of Last.fm and to the sparseness that this public interaction is not used too frequently, even between friends. And yeah, and what we found is that this simple local network measure of common friends is highly predictive, and this is also supported by other prior work in other networks. And also, this I can tell, the collaborative filtering experiments also showed that this information has the highest value. Okay, thanks for your attention.